How to use the initial rates method. We need to repeat an experiment several times using different initial concentrations of reactants. We usually only change one of the concentrations at a time, keeping the rest constant. But there are exam questions where you change more than one of the concentrations at a time. Calculate initial rate for each experiment. See how the initial concentrations affect the initial rates. Therefore, we can work out the order of each reactant. Once you know the order of each reaction, you can work out the rate equation. So pretty simple. Repeat an experiment several times using different initial concentration of reactants. Usually only change one of the concentrations at a time, keeping the rest constant. Calculate initial rate for each experiment. See how the initial concentrations affect the initial rates, and then therefore we can work out the order of each reactant. And then once you know the orders of each reaction, you can work out the rate equation. Now, measuring the initial reaction rate. For some reactions, a sudden color change happens when a product reaches a certain concentration. For some reactions, sudden color change when a product reaches a certain concentration. Iodine clock solution reaction you're monitoring: H2O2 aqueous plus 2I minus aqueous plus 2H plus aqueous, forming 2H2O liquid plus I2 aqueous. A small amount of sodium thiosulfate and starch added to the reaction mixture. Sodium thiosulfate reacts instantly with the iodine being formed. So once all the sodium thiosulfate has been used up, that's really important, then any more iodine form stays in the solution, turning the starch indicator blue-black. Varying the concentration of hydrogen peroxide and iodide while keeping everything else constant will give us different times for the color change, and therefore we can work out the reaction order. Varying the concentration of iodide or hydrogen peroxide while keeping everything else constant will give different times for the color change, therefore we can work out the reaction order. For reactions that produce a precipitate which clouds a solution, we measure the time taken for a mark underneath reaction vessel to disappear from view. For reactions that produce a precipitate which clouds the solution, measure the time it takes for a mark underneath the reaction vessel to disappear from view. For other reactions, we work out the initial reaction rate by measuring the time taken for a small amount of product to be formed.